Welcome to physics class. Today I will take you through physics experiment mainly on the part of electricity. So we are going to answer this question. Determine how the resistance of a conductor depends upon the length of the wire. So it means you have a different length of wire, that is nichrome wire. Then from those lengths we'll be able to come up with different resistance. I've been given 4 nichrome wire of different length, as well as crocodile clips, banana clips, connecting wires, voltmeter, ammeter, cell holder, 2 dry cells, as well as materials. We have 4 nichrome wires of different length. So this is 5 centimeter, one is 10 centimeter, as you can see from the ruler. Then this one is 15 centimeter, as you can see from the ruler. Then we have the last one is 20 centimeter. So then we have, this is the ruler, connecting wires, a switch. This is our switch. Then we have cell holder. These are banana clips, like the same as connecting wires. Dry cells. We have 1 voltmeter and 1 ammeter. Following the procedures, they are saying that we should arrange the apparatus as shown on the diagram. So, but to make these components to work properly or to give us accurate results, we need them to connect in this way. Starting with a cell. The cell, this is the positive side of the cell, so this one should be positive. The positive side should be connected to the positive side of ammeter, that's positive. Then the negative side of ammeter, that's the negative, should be connected straight to the negative side of a cell. So if we remove this symbol of voltmeter, it means our diagram will look like this. We have a positive side of a cell, then a switch. A switch doesn't matter if you connect it in both ends, it doesn't have a positive or negative. So a switch, you can connect it any other way. So a switch, then ammeter. Ammeter means we have a positive connected to the positive. Then the negative should be connected direct to the negative side of a cell. But to make this work properly, to make us to have to obtain different values, different lengths of nichrome wire will be connected between A and B. So this is our nichrome wire. But to make us answer the question of resistance, we need to have a voltmeter will help us to find voltage. So a voltmeter is connected across the components, so that is why it is connected here. Because our component is nichrome wire. So nichrome wire is our component, so we connect it. We connect the voltmeter here across the component. But the question should be, how are we going to connect it? So we are going to connect positive side of voltmeter should be connected to positive side of a cell, and the negative side of voltmeter, that's the negative, should be connected to the negative side of what? A cell. So our arrangement will be like this: positive side of cell connected to positive side of ammeter. The negative side should go straight to positive side of voltmeter. The negative side should go straight to the negative side of a cell. Arrange our apparatus in this way. We connect the banana clips on the ammeter, so it will be like this. And then the same banana clips to the voltmeter. A positive side of a cell to the positive side of ammeter, and the negative side of ammeter is connected to the negative side of a cell. But we have connected a component, and our component is a nichrome wire. So we can switch on the ammeter to see whether our arrangement is properly connected. So we can switch on the switch. So you can see the pointer has deflected to the positive side, meaning that our connection is just perfect. But we said for our diagram, or for us to find resistance, we need to connect a voltmeter. So a voltmeter is connected across the components. So this is our voltmeter, this is our positive side, this is our negative side. So positive side should be connected to the positive side of a cell. So this is the arrangement. So this is the positive side. The wire coming from positive side of a cell should be connected to positive side of voltmeter. So this is positive. Then the negative should be connected to the negative side. So we'll connect a negative here. So as you can see, the pointer from voltmeter has also deflected to the positive side, meaning to say our connection is just okay. So this is how we are going to be arranging our materials so that we should find different values of ammeter and voltmeter to help us to answer the question or to help us to find the values of resistance. So now we'll be connecting a different length of nichrome wire between this gap. That's AB. So we'll start with 5 centimeter nichrome wire. Then we'll check the readings of ammeter as well as voltmeter. Then we'll be recording on this paper. 5, then 10, 15, then we'll finish with 20. So we'll be using this table to record the values, then we'll transfer it on the board, then we'll draw a graph. So this is our 5 centimeter. Then we'll switch, we'll check if the ammeter has deflected. So you can see the ammeter has deflected to the positive side. Then we should also connect the voltmeter and see whether it will deflect. So positive side should be connected to the positive side, and the negative side should be connected to the negative. So it'll be like this. So you can see the voltmeter and ammeter both have deflected, and we have to collect a reading from ammeter as well as voltmeter. So you can see from 0 to 1 we have 10 demarcations. That's pointers. We have 10 pointers between 0 and 1. Each point is indicating 0.1. So each and every division here, we have 10 division. From 0 to 1, you have 10 division on voltmeter. From 0 to 1, you have 10 division on ammeter. But each division, its value is 0.1. So we can collect a reading from ammeter. Thus, our pointer is on 9. If it is on 9, it means our value is 0.9. So after connecting a nichrome wire, centimeter nichrome wire, it is giving us a ammeter reading of 0.9. While voltmeter reading is definitely 0.3. So we record 0.3. That's voltmeter. So ammeter is connected, is measured in amps, while voltmeter is measured in volts. Then we will change the length. We will connect a 10 centimeter nichrome wire. The values that we have obtained after connecting 5 centimeter, ammeter reading was 0.9 and voltmeter was 0.3, and after connecting 10 centimeter, ammeter reading was 0.7 and voltmeter was 0.5. After connecting 15, ammeter was 0.6 and voltmeter was 0.6. After connecting 20, ammeter was 0.5 and voltmeter was 5. So now we can find the value of resistance by using this formula. That's resistance is equal to voltage over current. So we'll be taking this value of voltage dividing with the value of what? and resistance is also what? Increasing. As the length is increasing, resistance is also what? Increasing. If you consider this formula, we are saying resistance is just equal to voltage over current. So it means resistance and voltage, they are directly proportional. If they are directly proportional, it means when resistance is increasing, voltage should also increase. So you can see voltage starting from 0.3 and it is increasing to 1. So resistance is increasing, voltage is also increasing. But using the same formula, resistance is inversely proportional to current. When we say it's inverse, it means when something is increasing, another one has to what? Has to decrease. So you can see from the current, current is decreasing. We are starting with 0.9 and the lowest value is 0.5. It means current is decreasing while resistance is what? Is it increasing? So current is supposed to decrease while voltage is supposed to what? To increase. Because voltage is very proportional to resistance. Values which you are going to obtain depending on the number of cells which you have connected, which you have used. So we have used 2 dry cells, but if you use 3 or 4, it means you obtain values different from what I have just obtained. So we have transferred the values on the table. So now let's plot a graph of resistance against length. Resistance should be on a vertical line, and the item or the quantity which is saying that it should be against, it is listed below or horizontally. So resistance, it will be indicated on vertical lines, while on horizontal lines we put values of length. So we have 0.4, 8, 1.2, 1.6, then 2. That means we are increasing with 0.4, moving from one value to another value. Then I will transfer my data from my table of values to the graph. So when the length was 0.5, the reading from resistance is 0.3. It means I'll just measure here where the 0.3 should be. So as I have already said, we are using 10 centimeter to move from one point to another. So from here to here is 10. So it means I'll just divide 10 pointer divided by 3. It means here is 0.2, this one is 0.2, that's at the middle. And then between this one and this one, it means will be between here, this is 3 at 7.5, so here is 3. So my 3 is here, this will be my 3, and my 5 is here. So on vertical lines I'll be moving horizontally. Here I'll be moving horizontally like this, dots, dots, dot, dot, dot. And then on horizontal line I'll be moving vertically, like this. So where the two lines meet, I'll put a star. So it means here I'll just indicate by star. The resistance is 0.3, while the length is 5. Then let's see on 10 centimeter. If you transfer the data from the table on the graph, it will look like this. That's to say, when the length was 5, the resistance was 0.5. So it means this star here, it is just demarcating or illustrating that when the length was 5, resistance was 0.3. And when the length was 10, resistance was 0.7. 0.7 is here between 0.4 and 0.8. So this star means when the length was 10, resistance was 0.7. And here we have another point. This point means when the length was 50, the resistance was 1. So this is 1 between 0.8 and 1.2. And we have another point which is here. This point means when the length was 20, resistance was 2. So if we use the ruler and take the line of best fit, it means it's only 2 lines which are connecting. This line, this point and this point are not connecting because they are out of phase. Transfer your data from the table and draw the graph. It means your graph should look like this. Okay? So it means reaching this far, we have answered question C. To answer question number D, which will say, what is the relationship between the length of the wire and resistance? The relationship will be obtained from the what? From the graph. We will obtain the relationship from the graph. That's to say, we have plotted the graph of resistance and against length, and the graph is giving us a straight line what? Graph. So because it's a straight line graph, the relationship of resistance and length will be directly proportional. Length was increasing, resistance was also what? Increasing. That is why we have plotted a straight line what? Graph. So reaching this point, it means we have answered all the question C and question D.